Carlsbad Caverns, located in New Mexico, was first established as a national park in 1930 and as a UN World Heritage Site in 1995. It is made of 83 caves formed from a Permian Age fossil reef. The deepest limestone cavern and third longest in the nation, the Lechuguilla Cave, is located in the complex. The cave is 1,597 feet deep and 216 kilometers long. The national park spans 46,766 acres, and every year 380,000 tourists will visit the park. Over the last 1,000 years, it has served as home to Native Americans, American settlers traveling west, and today still serves as home to 1 million Mexican free-tailed bats that live in the Bat Cave near the main natural entrance to the complex. The ancient reef, the Capitan Reef, which makes up Carlsbad Caverns, formed between 286 and 230 million years ago. It was located along a Permian coastline of the Delaware Basin that was part of Pangaea, the supercontinent. Rather than mainly being composed of coral, as reefs are today, the reef was composed of sponges, bryozins, horn corals, brachiopods, nautiloids, gastropods, trilobites, and crinoids. Sponges comprised a significant portion of the reef. The end of the Permian also represented the end of the Paleozoic era, which was marked by the largest known mass extinction. Approximately 90% of the species went extinct, including a number of species that made up the reef, such as the horn coral, most nautiloids, trilobites, and most crinoids. The reef was dead at the end of the Permian and covered with ocean floor sediment and salt from the evaporation of the ocean water. Marine fossils and ocean sediment form the Capitan limestone present today at Carlsbad Caverns. At the end of the Permian, the sea dried, the reef was killed off, and salts were left behind, including halite and gypsum, which preserved the reef. Tectonic movement, approximately 65 million years ago, caused by the geologic processes that form the Rocky Mountains, first began the uplift of the fossilized reef. Faults created from the extension of the basin and range crust in western North America around 6 million years ago produced horst and graben features that uplifted the region to its current state. Along with the Carlsbad Caverns complex, the Guadalupe mountain range was also formed during these tectonic events and is adjacent to the caverns, as well as being composed of the same limestone material. Over time, weathering further exposed the reef complex. The caverns are composed of soluble limestone that has undergone speleogenesis, the development of caves, in this case through the dissolution of limestone. Sulfuric acid played a major role in the development of the caves. Hydrogen sulfide-rich water migrated up into the rock from petroleum reservoirs beneath the Capitan limestone, mixed with oxygen and formed sulfuric acid that reacted with the limestone. Since oxygen is a key reactant in this process, the dissolution was occurring at the water table. As a result, the oldest caves are located towards the top of the formation, and over time the water table fell. Additional caves were formed below them. Gypsum is a byproduct of the reaction between sulfuric acid and limestone, so much of the cavern walls are coated with the mineral. Speleotherms are mineral deposits that create cave formations. In Carlsbad Caverns, they began forming after the hydrogen sulfide-rich water drained from the chambers. Rainwater percolated down into the chambers and mixed with carbon dioxide to form carbonic acid. The acidic water dissolved the limestone and carried it to the opening of the cave. As this water dripped from the ceiling of the cave, it left collections of the mineral at the drip site on the ceiling. Initially thin, hollow straw-like features would be created, called soda straws. Eventually the soda straws grew into larger stalactites. Some of the dissolved limestone could be carried by the falling drop of water and collect on the floor beneath the stalactite, forming stalagmites. The Hall of the White Giant contains a notably large white stalagmite. As they grow over time, they will eventually meet and fuse together to form a single column. Other formations, such as popcorn, helictites, and draperies, can also be seen in the caverns. If you would like to know more about Carlsbad Caverns and the geology associated with it, please visit nps.gov/cave for the National Park Service official website.